Hi, welcome back. So in this video, we will discuss about the proof of work, which is a very important concept around blockchain. So proof of work was the first consensus mechanism in the crypto market dated back to 2001. Although its origin dates back to 1990s, but its first practical implementation was in 2009 when Satoshi Nakamoto came up with the Bitcoin white paper. And in order to understand what proof of work is, we need to understand what the consensus mechanism is and why exactly is it needed. So let's first discuss what the consensus mechanism is. Now, in a centralized database, let's say a financial system, the database theoretically is managed by an administrator, which has access to say an add, update, or delete your records, right? Now, theoretically, if they want, they can ask for say that we owe them say $100 for that data, right? Uh, However, in a decentralized environment, and especially the blockchain, it operates differently. It has a distributed ledger and is self-governing. So now, suppose if one user on the network says that we owe them $1,000, that can be checked by the other nodes on the network and can be flagged as a fraud instantly, right? And this is where we need the consensus mechanism so that it have that check and balance, and it ensures that no one is conducting any fraud on that network. And one of the main reasons of having a consensus mechanism, or why do we need a consensus mechanism, is that it makes the entire ecosystem, that is the blockchain, reliable. It makes it fair, transparent, and efficient. So what consensus mechanism does is that it ensures that everyone is always in the same page. Now, what do we mean by that is that suppose that Bob sends $10 to Tom. Ideally, Bob's account should be debited and the Tom's account is to be credited, right? So in a centralized database, a transaction like this will be owned by an administrator and can be tampered with theoretically, right? However, on blockchain, this information will be stored in a decentralized ledger, which is absolutely public. But how do we ensure that everyone on the network are on the same page about this specific transaction that just happened between Bob and Tom? And this is exactly where the proof of work comes into the picture. So what is proof of work? Now, in theory, it is a consensus mechanism. But there is a lot more to it. So effectively, it is an algorithm to eliminate the phased uses of the computing power. Now, what does that mean? We'll discuss it later. However, the entire idea is to eliminate the issue of double spending on crypto projects, right? So before we discuss on the computing power, let's first understand what a double spending is. So what exactly is a double spending? Now, suppose in a similar use case, Bob has say $10 in his account, and what Bob does is that it sends say $10 each to Tom and Alice. Now, this should not be possible because Bob has just $10 in account, and he theoretically he cannot send $10 each to Alice and Tom. So what happens that in a centralized database, there will be a centralized authority which can verify that whether or not a specific transaction is possible or not. Like whether Bob can send those $10 both to the Alice or Tom or not. However, in case of the decentralized ecosystem like blockchain, this is where the proof of work comes into picture. And especially in this case, as for the case of double spending is concerned, it is very bad for any crypto project because what it does is that it creates duplicate tokens and essentially makes the project worthless as price cannot be predicted. So now, how a proof of work is able to achieve this and prevent double spending? So let's discuss how does a proof of work actually works. Now, what happens is that each block on the blockchain is essentially a list of transactions. So we know that each block contains many transactions. So for example, a block on the Bitcoin network consists of up to 100 transactions each. Now suppose Bob sends $100 to Tom and $5 to Alice. Now these two separate transactions in the network are again associated to a block. So as we discussed, that each block will have many transactions. Now each block is then attached to a previous block, forming a chain of blocks which we refer to as blockchain. Now miners essentially are a very important part of this entire proof of work process. So what happens is that the miners are essentially the ones that are participating in the blockchain to add a new block. So typically on a Bitcoin network, it takes up to say 10 minutes to find the winning proof of work in order to add any of the block and then basically propagate it to all the other nodes on the network. Okay, so essentially what happens during the process of mining is that mining a block on the network is essentially a very complex guesswork, right? So where miners randomly guess a password to a block. Now there's nothing like a password, but basically these are complex, cryptographic algorithm that they have to use in order to crack that block code. So these passwords are essentially, hash functions that depicts that a miner has spent a considerable amount of time in order to find that winning combination. Now, this is where the proof of work comes in. That is, you have the proof that you have spent considerable time in trying to find out that combination that works. Now, as a result, the miners who are on the network and whoever has been able to find out that winning combination are rewarded with cryptos, or they even get the transaction fee that are associated to that particular block, right? And as soon as the blocks are mined, these are then broadcasted to everyone on the network so that everyone on the network is on the same page. So in this entire process, the two transactions that went through. So the first transaction was Bob sending $10 to Alice, and then Bob sending $5 to maybe Tom. Now, if the Bob has already sent $10 to Alice, then essentially the second transaction is going to fail, right? And then once this entire transaction is processed and then sent back to the node, everyone on the network verifies it, and instantly the double spending issue is resolved. So this is all about what the proof of work is. So what are its pros and cons? Now, proof of work lately has been one of the critical points where blockchain as a technology is getting a lot of heat around. However, it comes up with both the pros and the cons. So the first pros is obviously it's secure, right? So why it's secure is that a proof of work makes the blockchain safe, reliable, permanent. It makes it more fair and transparent, and that it is able to do it because one need around 51% of the computational power in order to basically manipulate or create or do any or process any fraud transaction. Now, this 51% of the computational power of an entire network as big as Bitcoin will come into billions of dollars. So even to conduct a basic fraud, it would require billions of dollars of manipulations. The second is the consensus, as we discussed, that proof of work essentially works on the consensus mechanism. So the data on the blockchain is something that everyone would trust as it is, as counterfeit is not possible, right? And it is theoretically very, very difficult also. So let's look onto the cons now. And the first major con that proof of work has is the impact on environment. And this is particularly the point where they get a lot of heat. So as per the report, it is estimated that the amount of electricity that is being consumed by the Bitcoin network and all those computing power, it is actually equivalent to the amount of electricity that a country like as big as Switzerland would consume in a year. And this is one of the major cons that the proof of work projects currently has. The second one is the inability to scale. Now, as we discussed that in a blockchain network, each block consists of 100 transactions. Now, as soon as that block goes into the network, then each node will basically try to apply the cryptographic algorithm in order to crack that code, and then they will basically get that opportunity in order to validate those transactions. Now, this entire process is not just say cost ineffective because it requires a lot of computational power, but it also acts as a blocker for this entire technology to be used for mass use case, right? So currently, I mean, a single transaction on Bitcoin network might take up to say 10 minutes in order to process, and in Ethereum it ranges from say 10 seconds to 30 seconds on an average. And the third one is the no penalty. Now, what does that mean is that suppose a node who is basically processing the transactions in a block, if it validates or it processes a fraud transaction, right? Now, once this blocks is broadcasted into the network and goes to different nodes, then although we need a 51% consensus in order to mark it as the right transaction, however, even if suppose one of the transaction has been fraudulently approved by one of the nodes, there is no system of penalty here. Whereas in a centralized server, I mean, any specific say transaction which is basically fraud can be penalized by those authorities itself. So there is no penalties as far as say proof of work is concerned. So now, what are the projects that currently uses proof of work? So as we discussed, Bitcoin is the most famous one. Then there is an Ethereum, the Litecoin, and Bitcoin Cash. And there are a lot of other projects as well that currently uses proof of work. However, with all the disadvantages that proof of work has and the consensus mechanism that it provides, do we really have an alternative? We do have an alternative, and that is called as proof of stake. And we'll discuss about proof of stake in our next video. Thanks.